Welcome to the video on perpendicular bisectors. As always, thank you for the gift of your time. And as you watch the video, make sure that you get the most out of the time that you're investing and that you're watching for understanding, because that's the goal at the end of the video. You don't want to be just filling in the notes to make me happy or make mom and dad happy or to say that it's done. But you want to make the most of your time and make sure you watch with the idea of understanding in the back of your mind. So first things first, we want to talk a little bit about what a perpendicular bisector is. And the word perpendicular tells us that these two segments are going to meet at right angles. The word bisector tells us it's going to split in two equal or congruent parts. And I guess I'm going to backtrack just a little bit and talk about this two equal parts or two congruent parts. In order to split something into two congruent parts, we have to have something that's finitely long. For instance, with respect to a line, an angle, or even a ray, these geometric figures are all infinitely large, and there's no way that we could ever split them into two equal parts by meeting at right angles. So to get things straight right from the get-go, a perpendicular bisector is only for a line segment. So again, we're going to cut it into two equal parts in such a way that they meet at right angles, and that's what it means to be a perpendicular bisector. All right, so let's get this party started. We're moving onwards to example 1. It says, write an equation of the perpendicular bisector of the line segment connecting points A with coordinates 1, 5 and B with coordinates 7, 5. So since we've got this handy little graph here, the first thing that I'm going to do is go ahead and plot those points so that I have a very visual picture of exactly what's going on in this problem. So there's 1, 5. And there's 7, 5. And there's the line segment that I'm trying to bisect. So bisect, again, remember, means cut it into two equal pieces. I'm going to say, start right off the bat, that if we're going to cut this thing into two equal pieces, our bisector is going to have to pass through our midpoint. Now, there are lots of lines that we can draw that pass through the midpoint. There's one right there. There's a second one. Well, that one almost makes it, but you get the picture. There's a third one. In fact, I can probably draw infinitely many points that pass through the midpoint. But we want to do this in such a way that it's going to be perpendicular to line segment AB. So there is, in fact, only one line segment that I can draw that'll pass through line segment AB or pass through its midpoint and at the same time be perpendicular to line segment AB. And that is this fella right in here. So again, he passes through the midpoint of AB. He's perpendicular to AB. That makes him the perpendicular bisector of line segment AB. And as for his equation, if I look at the x-axis here, that pink dotted line crosses the x-axis at 1, 2, 3, 4, doesn't intersect the y-axis at all, and his equation, therefore, is x equals 4. All right, let's shoot down to the bottom of the page and try another one. Number 2 says, write the equation of the perpendicular bisector of the line segment connecting point C with coordinates 2, 6, and point B, coordinates 2, -9. So again, since they've provided this nice little graph for us, the first thing I'm going to do is plot those points so that I can get a visual of exactly what it is that we're trying to bisect. So there's the segment that we're trying to bisect. And if I approach this problem the same way I did the first one, I know that a bisector is going to have to pass through a line segment's midpoint. So if I try to count boxes like I did with the first one, I'm going to run into some trouble here. That line segment is 15 units long. So I know that each half of it is going to have to be 7.5 units long if I were to bisect it. So my midpoint is going to be right there. It's going to have coordinates 2, -1.5. So in order to be the perpendicular bisector, again, it's going to have to first of all pass through that purple midpoint. Second of all, be perpendicular to line segment CD. Since line segment CD is a perfectly vertical line segment, I know that its bisector is going to have to be perfectly horizontal. And this blue line, which represents the perpendicular bisector, passes through the y-axis at -1.5. And since it crosses the y-axis, it's going to have a y equals for an equation. And its equation is going to be y equals -1.5. Or if you prefer, y equals -3/2. All right, so that's the deal with line segments that are perfectly horizontal or perfectly vertical. How can we take what we've learned then and extend it to line segments that are slanted, that aren't perfectly vertical or aren't horizontal? Well, if we take what we did in both cases, we first of all had to find the midpoint, and that's still going to hold true. Second of all, we had to find the segment that was perpendicular, and that's still going to hold true. And in the past, you've learned some formulas that are going to help with both of these things. To find the midpoint, you have the midpoint formula. And as far as finding the perpendicular, we're going to use the slope formula because we know that segments with slopes that are negative reciprocals are perpendicular segments. So for number 3, this one too, I'm going to go ahead and plot these points. Point A has coordinates 3, 6. So there's point A. Point B has coordinates 5, 2. There's point B. So now there is my line segment AB. And again, if I follow the same steps that I followed before, I know that I need to find the midpoint. And in looking at the picture, I'm thinking the midpoint is right there with coordinates 4, 4. But I am going to use my midpoint formula to verify that. So anytime I use a formula in geometry, I'm first of all going to write it down on my paper. So I'm going to start by going ahead and writing the midpoint equals the average of the 2 x coordinates and the average of the 2 y coordinates. Remember, midpoint is exactly that. It's a point. It has an x coordinate and it has a y coordinate. To average two things together means to add them together and divide by 2. So I'm going to look at the x values, add them together, 3 plus 5, divided by 2. Average the 2 y coordinates, 6 and 2. So 6 plus 2, divided by 2. I'm going to grab my calculator if I need to and perform this math. 8 divided by 2 is 4. So just as I suspected, the midpoint does have coordinates 4, 4. So that takes care of the bisector part. Now I need my new segment to be perpendicular to this guy. And again, we're going to use slope formula to verify what is perpendicular. So again, anytime I use a formula, I'm going to write it down on my paper first. So change in y over change in x. Or if you prefer, y2 subtract y1 over x2 subtract x1. My 2 y values are 6 and 2. So 6 subtract 2. My x values are 3 and 5. So 3 subtract 5. So 6 subtract 2 is 4. 3 subtract 5 is -2. And when I simplify that fraction, I end up with -2 over 1. So I now know that the slope of segment AB is -2 over 1. I want the slope of a line that's perpendicular. And this is review. I'm going to use M for slope, but that little subscript perpendicular just as a reminder to myself that the slope I want for my new line is 1/2. So now I want my line to pass through the point whose coordinates are 4, 4. I want it to have a slope of 1/2. I'm set up beautifully to use the slope or point slope form of a line. So y subtract y1 equals m times x subtract x1. So the y value we want is 4. The slope we want is 1/2. The x value we want is 4. At that point, you are done. You don't need to go any further. Now, I do understand that looking at it in that form makes some of you uncomfortable because you like seeing lines written in the form y equals mx plus b. If that's the case, feel free to go ahead and distribute the 1/2 on the right side and then add 4 to both sides. So again, these two represent an equation for the same line. Both are correct. It's a matter of personal choice, what feels comfortable to you as to how you can go ahead and, or how you want to represent the equation for your line, for your perpendicular bisector. All right, what makes this difficult for kids sometimes, I think, is it's a lot of steps. You have to think about what a perpendicular bisector really means. You have to find the midpoint. You have to calculate or compute the slope. You have to remember to take the negative reciprocal in order to make those segments perpendicular to each other. And then you have to know how to write the equation of a line. Those are all things that we've done before, but now we're rolling them into one problem, and that can sometimes be overwhelming for kids. Let's go ahead and take a look at another one together. This one says, given points with coordinates 1, 2 for point P and -1, 3 for point Q, write an equation of the perpendicular bisector. Well, again, the very first thing that I'm going to do is go ahead and plot those points on my coordinate plane. So there's the segment that I'm trying to find my perpendicular bisector for. And keeping in mind our discussion before, I'm going to first of all find the midpoint. And there's what it looks like on the graph. This one isn't quite so neat and pretty as the first one was. So again, I'm going to verify algebraically exactly what the coordinates of my midpoint are. So I'm going to use the midpoint formula. And again, anytime I use a formula, I'm going to write it down. To average the two x's means to add them together and divide by 2. So my two x's here are 1 and -1. So 1 plus -1 divided by 2. Average the two y values. So again, to average two numbers, add them together, divide them by 2. So when all is said and done, the coordinates of the midpoint are 1, 5/2. And I'm going to represent that as a decimal as opposed to the fraction. But you can represent them however is comfortable or meaningful to you. And I just realized looking at my picture that these don't really check out. I thought that the midpoint was going to be 0, 2.5. And where did I make my mistake? If I go back up here and look, that was a -1. So 1 plus -1 is in fact 0. And 0 divided by 2 is going to be a 0. So this should be a 0. I'm glad I looked at my graph to verify and to check. All right, so now I have to find the line that's perpendicular to line segment QP. Well, in order to find perpendicular, I have to know what the slope of line segment PQ is. So I'm going to go find slope. And again, anytime I use a formula, I'm going to write it down. So slope is equal to change in y over change in x, or y2 minus y1 over x2 minus x1, whichever you prefer. So 2 subtract 3 over 1 subtract -1. So the numerator of my fraction becomes a -1. The denominator becomes a 2. So the slope of line segment PQ is -0.5. I want my slope to be perpendicular to that. So +2 or +2 over 1. So I want to pass through the point 0, 2.5. I want a slope that's equal to 2 over 1. I know the coordinates of a point. I know the slope. I'm perfectly set up to use point-slope form of an equation. Y minus y1 equals my slope times x minus x1. So I've got y, subtract my y value, 2.5, equals my slope, 2, times x, subtract my x coordinate, which is 0. At that point, I'm done. If I don't want to go any further, I don't have to. I'm going to go ahead and distribute because I know some of you are more comfortable seeing this in point or slope-intercept form. I'm going to add 2.5 to both sides. So again, it's a personal preference. If you prefer the equation written in black ink, that's perfectly acceptable. If you prefer the one that's written in blue, that's just as good. All right, at this point, I'm going to say if you're ready, go ahead and do example number 5 on your own. Write that equation of the perpendicular bisector. If you're feeling like you still need a walkthrough and you're still kind of sort of uncomfortable with this, then let's go and we'll do this one together. All right, given line segment GH with those coordinates, again, the very first thing I'm going to do is graph them. It was a good thing that I paid attention to the graph in the last problem, or I wouldn't have caught that mistake that I made. So there's G, there's H. I know that in order to be the perpendicular bisector, I have to pass through the midpoint. So I'm thinking the midpoint is going to be somewhere, yikes, it looks like right around there. But again, I'm going to verify this algebraically. So midpoint, I'm going to find it by averaging the 2 x values and by averaging the 2 y values. So my 2 x values here are -2 and 4. To average two things means to add them together and divide by 2. My 2 y values are 0 and 3. And again, to average them means to add them together and divide by 2. So this is 2 divided by 2, or 1. 3 divided by 2, or 1.5. So my midpoint is pretty much where I expected it to be, 1, 1.5. That takes care of the bisector part. Now I have to worry about perpendicular. Perpendicular, I'm going to find slope. So again, I write the formula down, change in y over change in x. My 2 y values are 0 and 3. And this guy doesn't want to sit still or stay still. So 0 over 3. The denominator of my fraction is going to become -2 subtract 4. So up on top, 0 subtract 3 is -3. -2 subtract 4 is going to become -6. So my slope here is going to be 1/2. But because I want these guys to be perpendicular, I'm going to have to remember to use the slope of a line that's perpendicular, which is going to make this guy -2 over 1. So there's my point. There's my slope. I'm all set up to use point-slope form of an equation. So y subtract 1.5 equals my slope, -2 times x subtract 1. And again, if I want to leave it like that, I'm all good. If I want to, I'm all set to go ahead and distribute so that I can put it in the form y equals mx plus b. And then I'm going to add 3/2 to both sides. So again, whichever form you're comfortable working with, that's the form that we're going to go with. I'm going to go ahead real quickly and just plot this new line and see if they really do look perpendicular. So there's my midpoint. I know I want my slope to be -2. So I'm going to go up 2 units and over 1, maybe up 2 and over another 1. And now I can graph that perpendicular bisector. And yeah, it does look pretty good. It looks pretty perpendicular. It passes through the y-axis at 3.5. I think I'm good to go. As always, thank you most graciously for the gift of your time. It's the most valuable thing you can give to me. If you're still having trouble, please, please, please feel free to rewatch the video. Feel free to ask questions when you come to class. Remember, there's extra help that you can seek in the math office. You can always shoot me an email. But we're going to work more on perpendicular bisectors the next time you come back to class.